Hello, Assalamu alaikum. My name is Khalid Mahmoud Sujon. So today I'm going to present my fyp-1. So to do that, I will take help uh, from my slides. So let's share my slide. Let me share my slide. So So first, I will talk about my title name, my thesis title name. So it was a fantastic name, Machine Learning Algorithm to Predict Student Performance in Higher Education Institution. So my supervisor was PS Dr. Ruhayanti bin Hassan, and I am really grateful to her because it was really a fantastic journey with her. She helped me a lot during the whole journey. So during our presentation, we will start with the first part, which is abstract. So in abstract, basically, I tried to depict the whole background of our study, the importance of machine learning algorithm to predict student grade in higher education institute and all. Beside that, I have talked about some sort of data processing technique. For example, how we can work with imbalanced data set. For example, we have talked about the application of smooth. Not only that, we have talked about the feature selection as well. So if I want to talk a little bit about the whole research outline of my FYP, I must say that I have started with introduction. Then in this presentation, I will talk about problem statement. Not only that, I will include objective, a little bit scope. I will talk about the literature review, research framework, confusion matrix, flowchart, data preparation, model training, performance analysis, future direction, and lastly, I will end our presentation with the conclusion. So let's start with the introduction. So here I have talked about the traditional methodology. With the traditional grading methodology, we are facing so many problems. So by employing logistic regression and random forest, which is one of the most popular machine learning algorithm, right? We can solve those problems in this higher education institute. We address the challenges of imbalanced data set by incorporating, for example, synthetic minority oversampling technique. In short, we will call it SMOOT. And not only that, we will focus on feature selection as well. That will enhance the accuracy of our prediction model. By using feature selection, we will focus on the important feature, the essential feature of our data set. Now, let's talk about the problem statement because every study problem statement or problem formulation is the background of any particular study. So in problem statement one, we focused on the outdated evaluation system right now we are having. So the current evaluation system relies on traditional characteristics, for example, learning activities, socioeconomic position, providing inadequate, inaccurately predicting student performance. The urgent need, okay, for improvement prompts the exploration of advanced technique like segregation and random forest to enhance prediction accuracy. In problem statement two, we will talk about the emerging technologies gap, right? As predictive analysis gains popularity in higher education, right now there is being a lot of studies right now based on predictive analysis. Our current evaluation methods struggle to keep up traditional appearance rooted in learning activities and socioeconomic factors. For short in predicting academic success, bridging this gap requires leveraging machine learning algorithms such as logistic regression and random forest to provide educators with accurate insights for informed decision making and effective support. Okay, and then we will talk about the objective of our FYP, of our study or thesis. So our first primary objective is we will compare two most popular machine learning algorithm, and we will see which algorithm is showing more a good prediction, which for example, we will compare logistic regression and random forest to predict student final grades. We will collect and analyze diverse academic and non-academic data, including student demographics, attendance, previous academic performance, and extracurricular activities to enhance predictive models. In our study, we focused on students' previous marks, for example, assignment marks, quiz marks, and all. And our second objective will be enhancing predictive model. So we will further investigate the impact of synthetic minority oversampling technique. In short, we will call it smooth and feature selection with logistic regression and random forest. Those two machine learning algorithm we are focusing. So basically, we will do two phase. It will be around two phase. So initially, we will and try to work with the data set, and we will directly train our model based on that data set. If we notice any overfitting or any kind of things, we will apply those smooth and we will observe the result after applying smooth, after applying feature selection as well. And third objective, evaluating predictive analysis impact. So we will evaluate the overall impact of predictive analytics on higher education institute. We will analyze LR and RA predictive models, for example, to evaluate our model, how much accurate it is. We will focus on some sort of evaluation matrices. For example, we will focus on precision, we will focus on recall, we will focus on FR score and ROC out as well. And we will provide a comprehensive understanding of the effectiveness of our model as well. So let's go through a little bit about the scope. So first of all, data collection scope. So basically, we are working with the data set. The size of the data, it contains the information, okay, about 410 students. So we collected the data from an AI course of UTM. The data contains so many features, for example, test marks, midterm marks, assignment marks, quizzes marks, project marks, and then final exam marks as well. So yeah, the algorithm implementation, as I mentioned earlier, we are focusing on two popular machine learning algorithm, random forest and logistic regression. Not only that, predictive analysis impact, we will find out that too. And to evaluate our models, we will focus on some sort of evaluation matrices such as accuracy, precision, recall, and F1 score as well. Now, I am going to talk about a very important thing, which is our existing study or literature review. So what I did in my FYP report, I have included so many studies that have been conducted based on this topic. So that has cemented my fascination. And then I tried to summarize the whole thing in this bar chart. So if we notice that most of the study focused on decision tree. Most of the study they have conducted, they were using decision tree and then naive Bayes and random forest. But interesting factor is that when we were studying that, although most of the study had been conducted based on decision tree, these studies collectively suggest that decision tree stands as a more popular approach to predicting student grade compared to random forest. However, it's crucial to recognize that model performance depends on the specific data set and the chosen features. So in most of the cases when we were doing literature review on that time, I noticed that they were focusing previous exam grades and all. But in our data set, for our specific real-time data set, we are focusing on different features. That's why we have decided to work with logistic regression and random forest. And one thing I want to put here, random forest play a vital role for imbalanced data set. So that's why we are working with logistic regression and the random forest, and we will do further ado. And then let's talk a little bit about my research framework. So it will contain around 4 phases. First of all, I have started with data preparation, data pre-processing and design model, and performance analysis and visualization as well. So we have collected a data set by the name of AI course, and then we have extracted the data and so on. And then we will focus on data pre-processing and performance analysis. And finally, we will visualize our data. Okay. Then now I'm going to talk about a very important part of this research. We have made this confusion matrix, because we know that by using confusion matrix, we will get an easy and clear idea about the accuracy of our model. So the class level will be a level, for example, with this expression, okay, A, B, C, D, E, and all. And now let's talk about the flow of our work. So as I told you earlier, the total number of data we have 410, and initial number of attribute around 12, and number of classification 5. So the things that we have categorize our data into five categories based on their grade: distinction, pass, fail, exceptional, excellent, and so on. So that's why they are the number of classification. So we have started with the importing raw data set, and we will do data pre-processing, and we will select the classification. For example, we are working with logistic regression and random forest. Not only that, we will perform the analysis as well. To perform the analysis, we will split our data set into two parts. The ratio of the splitting will be 80/20. For example, the training set will be 80%. We will train our model with 80% of our data that we have, 410 data, and then we will rest of the data, which is 20, will be used to evaluate our model, that will be called as testing data. And finally, we will evaluate our model based on those evaluation metrics: accuracy, precision, recall, and F1 measures as well. And we will show the insights which predictive model is showing best performance. So that will be our flow of work. Now let's talk a little bit about the data preparation. In data preparation, we have employed, I was working in Google Colab. So in Google Colab, I have first imported the data, AI data set, and later on, I was using some sort of libraries of pandas. And then I was trying to find out the class distribution so that I can get a clear idea about the distribution of my classes. Let's say, as I told you earlier, that we have around 5 categories of data. So distinction contains around 273 of data, which is quite high. And pass contains 77, excellent contains 41, and fail contains 50, and exceptional contains 4. So from our outlook, we can see that data is not that much balanced for sure, but we will explore it further. Then we are using here level encoder, which is an encoding method. We know we have two type of encoder method, one hot encoder and level encoder. We are using level encoder here to encode our categorical data for grade. For example, I have A plus, B minus, and all. So as it is categorical data, so I am using level encoder here. Not only that, here I have included how I have splitted the data set here, and then I have included the standardization as well. Now, after completing the data pre-processing, we will focus on the model training. As I mentioned earlier, we are focusing on logistic regression and random forest. So this is the implementation of our logistic regression. This is the implementation of our random forest as well. And now let's talk about the performance analysis, which is the most important thing. So interestingly, when I was running or when I was training and running the model, I saw that the accuracy performance is around 1. That means 100% accuracy. So if I want to talk a little bit about the performance analysis, I would suggest that, let me go here. Yeah. So as I told you earlier at the beginning of our presentation, that our performance analysis or to evaluate our model, how much accuracy we are getting from this model, we will focus on some evaluation matrices. For example, we will focus on precision, we will focus on recall, we will focus on F1 matrix, we will focus on support as well. So here we can see that all the evaluation metrics is showing 100% accuracy. I think that sounds really good, but the important thing is that although uh, 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 these findings are really encouraging and smooth, but we will examine more to check overfitting, right? To resolve any potential imbalances. Because in our class distribution, we notice that our data set is not balanced. So in our future direction, that means in FYP2, in our primary research, we have noticed that the accuracy for all evaluation metrics are 100%. For example, recall, accuracy, precision, and F1 score in all classes. Although these findings, as I told you earlier, are really encouraging and fantastic to see, but we will check overfitting to resolve any potential imbalances. Not only that, for this, we will use data balancing technique. As I told you earlier, smooth synthetic minority oversampling technique. Not only that, we will focus on feature selection as well. So to solve this concern, our plan to for the second phase of our final year project, which is FYP2, involves implementing various strategies like data balancing technique, feature selection, and one important thing we will do in this study, we have split our data set. 20, the ratio was 20-80. That means testing was 20%, training was 80%. But in our FYP2, we will focus on data split into, we will split the data set into 25 as 75 and 30-70. Not only that, we will focus on 40-60 as well, and we will observe there is there any big differences then. Now, let's come to the conclusion. We have run our model for initial result. We run logistic regression and random forest to predict our student grade. Not only that, we have split the data set in training and testing data set, and the ratio was 20-80. We have created confusion matrix too. We trained the model with the training matrix. The accuracy was 1, that means 100% for all evaluation matrix, but gives us a clear instruction for further approach for our FYP2, where we will explore more about our model. We will explore the data overfitting and we will use oversampling method like smooth tool. So thank you very, very much. That's all for today. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.